Now we're going to be looking at solving absolute value inequalities. Now I want us to actually think about what it means for the absolute value of x to be less than 3. So remember, absolute value is the distance away from 0. So we want our distance away from 0 to be less than 3 units. So on a number line, if I want my distance to be less than 3, so that's going to be 1, 2, 3. That's going to include all of these values. But remember, we can also go in the negative direction, so that's going to be 1, 2, 3 in the negative direction. Now it does not actually include 3 away. It has to be less than 3. So hopefully we can recognize this type of graph as an AND compound inequality. So anytime you have a less than absolute value inequality, it's actually an AND compound inequality. So how do we go from having the absolute value less than inequality into the AND inequality? Well, let's go ahead and look at the graph again. So I'm just some distance a away from 0. Okay, a can represent anything. Since I have only a less than sign, I'm just going to be an open circle there. And I want to be less than a away from 0. So that includes all these values as well as these values. So we talked about how this looks like an AND inequality. So if I was going straight from the graph to the inequality, I would say x is literally between a and negative a. So if I wanted to go from having the absolute value less than inequality into the AND inequality, you take what's inside the absolute value once it's isolated. So make sure that the absolute value is completely isolated. You rewrite that exactly how you see it. You're going to keep the less than, and then you're going to keep exactly what you see to the right of the less than symbol once it's isolated. And then it looks like down here what we did is we used the same exact inequality on the other side of x, and then we just changed the sign of a. We want to find the solutions for the absolute value of 2x minus 1 less than 5. Now in order to do this, we need to drop the absolute value bars. But the only way I'm allowed to drop the absolute value bars is by rewriting it as an AND compound inequality. So remember, we rewrite everything that's on the inside exactly how it looks. We copy down the same exact inequality, and we copy down exactly what's on the right-hand side of the inequality. Now we're going to take that same inequality and put it in front of the stuff that came out of the absolute value bars, and then we're going to rewrite what's on the right-hand side, except for we're going to change the sign. And now we solve it inside out just like we normally would. So add 1 to each side. Everything you do to the middle, you do to each side. Divide everything by 2. So x is literally between negative 2 and 3. So I'm going to graph that on my number line here. I'm going to have open circles at negative 2, open circle at 3, and I'm going to shade between. And this looks like an AND inequality because it is. So here is my solution, and here's the graph of that solution. So what if I have an absolute value inequality that now has a greater than symbol? So if I have a greater than symbol, let's think about what that means. We want all the values of x that are 3 or more units away from 0. So I'm going to graph this and see what that looks like. So because I have an equal to sign here, I'm going to have closed dot at 3, and I'm going to be 3 or more. So where are the values bigger than 3? Well, they're this way. Or remember, I can go 3 the opposite way and go 1, 2, 3, closed dot because I'm equal to. 3 or more, I can go to the left. So hopefully you recognize this as an OR compound inequality. So we want to rewrite the absolute value inequality into an OR inequality. So let's go ahead and take a look at what that looks like again on a number line, just using some generic number A now. We want to be A distance away or greater. Here we're going to be not equal to and bigger, not equal to and less than. So if I was just looking at the graph and I wanted to write the inequality, well, this is very easily x is less than negative A or x is greater than positive A. So how we go from here to here, well, you rewrite what's in the absolute value bars and then you copy down exactly what you see on the outside of the absolute value bars, including the inequality and anything to the right of the inequality. Then we're going to include our OR, and then you write down anything you see in the absolute value bar again. But notice here, we flip the sign and make whatever is on the outside negative. So we're going to flip the sign and make it negative. Now remember, this is always assuming that the absolute value is completely isolated before you rewrite it into an OR inequality. So make sure the absolute value is isolated before you try to rewrite it. We want to find the solutions of the absolute value of 2x plus 4 greater than or equal to 6. So in order to do this, since it's completely isolated, we go ahead and we rewrite everything that we see inside the absolute value bars, copy down the inequality symbol exactly how we see it, and then copy down everything on the right-hand side. Or, again, same thing, exactly how you see it on the inside of the absolute value bars, but now we're going to flip the inequality as well as change the sign. Now we solve everything like we normally would. Don't forget to bring down that OR, that's very important. And now graphing this, we need the important points of -5, and +1. We're going to have an closed circle on 1, and it says x greater than or equal to 1, so we're going to shade everything greater than or equal to 1. And then we're going to have a closed circle on -5. And then we want everything less than or equal to -5, so we're going to shade to the left. So here's my solution, and there's the graph that matches my solution. So here's a little summary of the different types of solutions whenever we have absolute value statements. So here's the summary of absolute value equations. If I have a less than inequality, it's going to become an AND compound inequality. If I have a greater than inequality, it's going to become an OR compound inequality. One way to try to help you remember this, greater, so greater absolute value inequalities are OR, less than inequalities are AND, or you can remember the acronym GO LA. So GO, greater is OR, LA, less than is AND. So give these a try and make sure that you graph each of your solutions.